Let's now take a look at Wi-Fi networks authentication methods. There are 3 authentication options. Access points might perform authentication without verifying user identity. If that's the case, anybody can connect to the wireless LAN. User identity can be verified through checking if they know a shared secret. Keys are usually submitted while a client is trying to connect to the protected network. It's crucial that you understand that these two are completely different technologies. One is used for authentication. We're talking about that now. The other ensures the confidentiality of data. We'll cover this in a moment. The third wireless authentication method involves the use of a radius server and 802.11x protocols. We've already talked about this set of protocols. To quickly remind you, in this case, an access point is configured as a radius server client. Using the EAP protocol, the radius server forwards the client-submitted authentication credentials. The server verifies the user's identity. If you use a radius server and the 802.11x protocol, shared secrets are not used. Each user has his own password. He logs onto his account and his identity is verified. This solution is both more secure and more functional. The 3 authentication methods can be used together with various encryption methods. Not all combinations will be a good fit, but you can try several of them. We've already mentioned open system networks that don't perform user verification. This is a part of the 802.11 standard. It's enough to submit the name of an open network and connect to it. A network name field can also be referred to as an SSID or a network identifier. They signify the same thing. The legality of connecting to other people's open wireless networks varies depending on a country. In the Netherlands, for example, an active intrusion to a protected wireless network is not considered a crime. It's similar for Germany. While it is a crime there, it's seen as the fault of the wireless service providers who jeopardize the safety of their customers by providing them with insufficient protection. In the majority of countries, however, it's the attacker who will be held responsible for the act. In the case of open networks, the identities of users and computers are verified against the MAC addresses of network cards. An open wireless network can also use encryption for transmitted data. Web security is used for this purpose. Open system authentication with web key encryption means the validity of the web keys will not be verified. Since frames are encrypted with this key, an access point will reject the frames that can't be decrypted. The second protection measure is using a preshared key. It's a hugely popular authentication method in home LANs. Before I move on to describe how clients are authenticated, I'll talk a bit about the drawbacks of this solution. If more than 2 persons share a secret, it's no longer a secret. A key must be submitted in all computers that want to establish a connection with a given wireless LAN. There's no mechanism for that, so we do it manually. That's why we will probably never change a set key. A shared secret which is not a secret and is never changed doesn't guarantee any security. We'll discover this in the second part of our module. Leaving aside the questions of authentication effectiveness, let's now see how this process looks. The technique makes use of the challenge and response mechanism we already know. A client attempts to contact a selected wireless LAN. An access point generates a pseudo-random challenge message and sends it to the client. The client has to then encrypt the received challenge with the preshared key, PSK, and send the encrypted response to the access point. Next, the AP decrypts the ciphertext and compares it against the challenge it sent earlier. If the results match, this means that the same key was used to encrypt and decrypt the message, implying that the client was in possession of the key and was authorized to connect to the VLAN. The system for sending challenge and response messages is not protected in any way. Note that the key itself is not transmitted over a network. Only the data encrypted with the key is transmitted. When you examine threats related to Wi-Fi security, it'll turn out that the process can be reversed. By intercepting the challenge and response messages, we can extract the PSK. Since all users share the key, all users share also medium access. In those VLANs that use PSK user authentication, all users have access to the same medium. This is like being in a local area network connected with hubs. Packets are received by all clients. It depends on the mode used by the receiver's network card to reject the packets that aren't addressed to it, or to choose to intercept and modify them. The only secure method for verifying wireless network user identity is provided by the use of the 802.11x standard. If you configure an access point as a Radius server client, you will need to submit a shared secret. In this case, the secret will be shared by the access points in the Radius server, and not by the X network users. This will allow the AP to check the identity of users who want to establish a connection. Each person will have their own identity. Each person will have their own secret. For example, the password stored in the Active Directory. This means that the Radius server will be an Active Directory server client. It will forward questions usually according to this pattern. First, it will ask whether the user who claims to be Bob has already submitted a correct password. The next request will ask for proof that a given user is authorized to connect to an office VLAN using Wi-Fi. A more secure version of this mechanism verifies the identity of users or computers against their certificates. This does seem very complicated. Other than an access point, you'd need a computer used as a Radius server and also a domain controller for this. As you see, the infrastructure is extensive. This is why this solution is not generally deployed in home VLANs. While it does bring a lot more security, it's excessive if there are only 3 or 4 users in a home network. As for business VLANs with 5 or more users, however, I'd strongly recommend configuring a computer as a domain controller or as a Radius server. We'll see that this solution will secure a network against all known attacks.